Let's look at a couple more examples of solving systems of nonlinear equations. This system of equations is going to be two parabolas. Now there are several possibilities with two parabolas. I mean, we could have two parabolas that kind of cross over each other at one point. We could have two parabolas that cross at 2 points. We could have two parabolas that never cross. I suppose we could also have two parabolas that cross at 2 points this way, or cross at 1 point this way, or cross at no points that way. So I think the only possibilities are going to be 0 points, 1 point, 2 points, or we could have two parabolas right on top of each other that cross everywhere, so infinite number of points. So let's see what we have with these problems here. Let's go ahead and do our graph first, and then we'll work on our algebra. So let's see, the first equation we have a shift up 2, so I'll put my vertex 0, 2, and then I have a compression of 1/2, so instead of going over 1 up 1, over 2 up 4, over 3 up 9, I'll go over 1 and up half, and then over 2, instead of 4, I only go up halfway to 2. And then over 3, and instead of 9, I'm going to go half of that, which is 4.5. 1, 2, 3, 4.5. And on the other side as well. Whoops. Let's get that in the right spot. And then graph my parabola. Try and ignore my little drawings over here. My other graph, my other parabola is y equals x squared minus 6. That's a shift down 6, and then it's going to have a regular growing pattern, so over 1 up 1, over 2 up 4, over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9, and just for fun let's go over 4 and up 16. So there's 9, 10, 11, 12, 13, 14, 15, 16. So it looks to me like our intersections are going to be way up there. Let's go ahead and solve these algebraically. Again, with that same strategy, since I have y equals and y equals, we'll just set the two equal to each other. So I have 1/2 x squared plus 2 equals x squared minus 6, and we'll solve for x. So I'll subtract my 1/2 x squared, and I can subtract my 2, so I get 0 equals 1/2 x squared minus 8. Now this is still a quadratic equation, but since it has no x term, I can actually just use the square root method, which means I'm going to isolate my x squared and then take the square root of both sides. So I will go ahead and add my 8 over. So 1/2 x squared equals 8. And then multiply by 2 to get rid of that 1/2 in front. So x squared equals 16. And then take the square root of both sides. Gives me x equals, don't forget the plus and minus, x equals plus and minus 4. So I'm going to go ahead and substitute those into one of the two equations. I guess y equals x squared minus 6 probably looks easier, so I'll do that. So if I have x equals 4, that's going to give me y equals 4 squared minus 6, which is 16 minus 6, or 10. So I get an ordered pair, 4, 10. And then when I substitute x equals negative 4, that gives me y equals negative 4 squared minus 6. So that's 16 minus 6 again. So my other ordered pair is negative 4, 10. So if I look at my graph, let's see if that makes sense. 1, 2, 3, 4. So negative 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 4, 10. And 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 10. Yay, so the graph and the algebra, again, working together. So this system would have two solutions, two ordered pairs. Let's look at another system that has two parabolas. So here we have y equals x squared minus 10x plus 20 and y equals x squared. Let's get those graphed on there. I'm going to graph y equals x squared first because it's just the parent graph. So vertex at 0, 0, over 1, up 1, over 2, up 4, over 3, up 9, 5, 6, 7, 8, 9. And the other parabola is in standard form. So the easiest way for me to graph that one is going to be to find the vertex. So remember that the vertex is found by doing the opposite of b over 2a for your x value. So x will equal positive 10 over 2 times 1. So x is 5. And then I have to substitute 5 in for x to get y. So y equals 5 squared minus 10 times 5 plus 20. So that is 25 minus 50 plus 20, which is 25 minus 50 is negative 25, plus 20 would be negative 5. So my vertex is going to be at 5, negative 5. Looking at my coefficient of the x squared, that a value is 1, so that tells me that the growing pattern is not stretched or compressed. So if I just go to my vertex at 5, negative 5, 1, 2, 3, 4, 5, 2, 5, negative 5, then I can just use the regular pattern of over 1, up 1, over 2, up 4, and over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look at that. I might just go one more, over 4 and up 16. So there's 9, 10, 11, 12, 13, 14, 15, 16. And graph that parabola. Oops. That's kind of a sketchy parabola. Okay, so it looks like this parabola, this system of equations is only going to have one solution. We'll see what we get when we use algebra. So I'll use that same approach. So I'll set x squared minus 10x plus 20 equal to x squared. Now when I start solving that, I will subtract x squared, and those two cancel out, so I get negative 10x plus 20 equals 0. Now that is not a quadratic equation, that's linear, so what I'm going to do to solve that is isolate the x. So I'll go ahead and subtract 20. So I get negative 10x equals negative 20. Divide by negative 10. That gives me x equals 2. To get the y value, I'm going to sub that into one of my two equations. I'm going to pick y equals x squared because that definitely looks easier. So y is going to be 2 squared, which is 4. So that tells me my solution is 2 for the x value, 4 for the y value. which is 1, 2, 1, 2, 3, 4, right here at 2, 4 on my graph. So I will box that and call it good.